This tutorial on the Pandas library is going to be concise and explained very simply. To use the Pandas library, we'll do import pandas as PD. Pandas is generally used for looking at data in tables, and in Google Colab we always have this data here in sample data / California housing train.csv. To do this, since it's a CSV, and often it will be, we'll do pd.readcsv, and then we'll pass the name of the file here, which is sample data / California housing train.csv. We can see it opens up this massive data set which has 17,000 rows and 9 columns. It's only going to show about 10 of the rows by default, but the whole data set is stored in this thing, and so we'll make a variable and set it equal to that. We'll call it df, and I'll explain why shortly. And if I call df.head instead, what that does is shows the first 5 results. The whole data set is stored in df, except we're only going to display the top 5 because it hurts our eyes less that way. Now what this data set actually represents is a bunch of information on housing in California. Each row is one particular region of California, and it has some latitude and longitude, which is its location, of all the houses that are in this location, the total number of rooms, the total number of bedrooms, the population, and so on. Now I called this variable df, and we very commonly use that because if we ask the type of this object, what it is a pandas data frame, so that's the df right there. This is the main object in pandas because it's for dealing with tabular data. It's a frame or a table of data. The other main object in pandas is a series, which is really just one column of data. And to get a series, we can do df, and then we ask in square brackets here, give it a string, which is a column name. And so maybe we'll ask households here, the number of households. And if we put that in the string in the square brackets, we can get just this one column. We'll see that this 0 and this 472 matches up right here because it's all the exact same information, just this column. Again, we don't really wish to look at the whole data set, and so we'll do .head, and we'll see that if we ask the type of what this thing is, I'll just call this households, for example. I'll do .h is that, and then we'll get rid of .head over here, and then here, if we ask the type of HH, we get that it is a pandas series. These are the two main objects in pandas, a table of data or a series, a column of data. So for now, I'm going to show a lot of the details on series or just one column, and then we'll extend that to data frames after. So we can ask questions like, what is the mean value of this, or what is the average? We'll do hh.mean, and that says the average is 501. We sum up all of the 17,000 values here, and then we divide by 17,000 to get the average of 501. Another question we might ask is, what is the standard deviation? We'll do std for that. The higher this value is, the more spread or variation there is in the data. It's less concentrated around this mean value here. We can ask many other common questions, and I'll show them all at once just by putting it in a tuple here. We'll do hh.min, hh.max, count. Minimum is 1, the maximum is 6,082, and the count is 17,000. The count should make sense because we have 17,000 items. We already knew that because this is just a column of a table where we had 17,000 rows in this thing. The minimum value of all of the households is 1, and the maximum value of all the households is 6,082. Finally, I might want to know what the median value is, which is basically just if you lined up all of them in order, you got the middle value, 409, which is generally somewhat close to the mean, although not always. If I didn't want to have to think about all these different things I might be interested in the dataset, well, I can just do this column .describe. Basically gives me all of these things, the count, there's 17,000, the mean, the standard deviation, they're all the same values here. The only thing we didn't look at is the 25th and 75th percentile. The 50th is actually the median right here. If we go back to our whole data frame for a moment, we'll see so many different columns. Well, what if we wanted to instead not look at one particular column and also not look at the whole data set, but just look at maybe 2 columns? Let's look at maybe total rooms and total bedrooms, since they're kind of similar. So down here, we can get that information with df sub, and instead of just giving this one string here as it's suggesting for us, if we actually put another square brackets here and give a list in strings of column names that we want. And so maybe we'll pass it total bedrooms and total rooms here. So if I do exactly that, I'll ask total bedrooms and total rooms, then what we get again is a data frame object that has the same number of rows, but just these 2 columns. Again, we don't really want to look at this particular huge thing, so we'll just do .head. For simplicity, I'm going to make this a new variable, and so I'll just call it basically rooms is equal to this, and then instead of outputting that, we'll output rooms.head, and it's the same thing just with the variable. And now what we can do is the same thing as above. We can ask maybe what is the minimum value here? Well, this is going to give us 2 things. It's going to give us the minimum of all the total bedrooms and the minimum for all the total rooms. And we can ask all of the same questions as above, but again, we can also just do .describe. That gives us all of these same sets of things except for both of the columns. columns. So just to pick off a couple values for fun, the standard deviation or measure of spread in the total bedrooms is 421, and the median value for the total rooms is 2,127. This is an extremely good check to make sure our data actually makes sense. For example, we better make sure that the minimum value for the total bedrooms is at least 1 or at least 0. We can't have a negative number of bedrooms, and we'd also expect it to be a flat number rather than like 0.2 or 0.45 of a bedroom. That doesn't really make sense either. So describe is a great way to give a bunch of useful information and figure out what's going on in either a whole data set or just a column, except it's not always the thing that we'd want to do because it's pretty confusing sometimes. We might just want to graph and visualize the data by looking at a picture of it. We'll look at HH up here, our households. Down here we can write hh.hist, and this makes what's called a histogram of the data. And it shows us visually none of the values are less than 0. So on the x-axis, this is the actual value of the data, and the y-axis, this is how many of the values are in this range. So it's saying about 13,000 of the values are between 0 and 500 or so. 3,500 are between 500 and 1,000, and we can see it gets smaller and smaller, such that at the very end here, at almost 4,000 mark, we have basically just 1 or 2 values in here that actually have that many households. We can again also do this for a data frame, which will produce just a histogram for each of the columns, so we can do df.hist, but I warn you, it doesn't always produce a nice, good-looking result, although it will definitely give a histogram for all of the columns. In this video, I won't be covering the NumPy library, but if you want to know how to convert it to a NumPy library at any point, you just do df.to_numpy, and it converts all the data into a NumPy array. But I'm going to leave that commented because it's not really that important. Now let's again look at our rooms, where we had basically just these two columns, total bedrooms and total rooms. There's a lot of things you can do with a data frame, except with dealing with the whole thing, it gets kind of confusing. So we're going to do it with just these two columns here. Something we might want to do is plot the correlation or scatter plot between these two columns. So this type of plot is going to work perfectly for two columns because we're putting one of them, the total bedrooms, on the x-axis and the total rooms on the y-axis, where a point is going to be shown by this x and this y. And what we can do is write simply rooms.plot.scatter. So we're making what's called a scatter plot. That we can see here it's asking for x and the y. We can actually just make these strings, which are the names of the columns. And so here we'll write total bedrooms to put that on the x-axis. The other one is total rooms. We'll put that on the y-axis. And what this produces is a scatter plot where each of these blue things is this x and this y, this x and this y. We can see two main patterns. One is that kind of fans out like this, and the other is that as total bedrooms increases, total rooms increases. So we call this a positive correlation, and we can actually ask the correlation down below. It's just a value. If we type rooms.core, it's going to show 4 values, except only one of them is actually interesting to us, and that is 0.928. The closer this value is to 1, the stronger the relationship between these two is. As in, the more confident that we are, that is the one increases, the other one increases. This value is either positive or negative, and if it was negative, this would go down like this as a diagonal. As one increases, the other one decreases. And again, something scary that we're probably not going to do because it's bad on the eyes. If we do df, so the entire data frame from before, if we ask the core on that, it's going to give the correlation across every single combination. For example, our total bedrooms and total rooms combination is going to be total bedrooms, total rooms right here. We see our 0.928 as in above, but this thing is terrifying. So again, I'm kind of commented out and hide it, but just know that you can if you want to. Now that's as far as into the statistics stuff I'm going to go. There's a lot more you could look at here, but now we're going to focus on what Pandas is really good at, which is manipulating the data frame objects. Now let's take a closer look at our rooms data frame. So we have two columns, total bedrooms and total rooms, and you can see we haven't really talked about it. This is this index column. So if we actually happen to know a particular value of the index that we want to look up the values for, maybe I was interested in this information right here. So I could ask rooms.loc and then pass this square brackets thing and then give the number. If I gave it 3, that is going to look up the information for this row here. So it says the total bedrooms is 337 and the total rooms is 1501. We can actually look up what this thing is by calling rooms.index. And this says it's a range index from start at 0 to stop is 17,001 with a step of 1, which makes sense. We can see if you know the Python range function, it's basically each of these values in this range. Now, most of the time we don't actually know the index value of interest to us for lookup. What we want instead is based off of some particular values in the dataset. So maybe I wanted only the rows that had a total bedrooms bigger than, say, 326. Now, before we do this, let's actually build up to it. So we can grab a column as we saw. Let's grab the total bedrooms column by doing total bedrooms is equal to rooms sub just total bedrooms. And then if we look at the head of that, we'll see just the first 5 values here. Notice we can actually convert this into what's either a true or false at each of these values, where if we're setting, say, total bedrooms is greater than 325, for example, well, then that converts everything into either true or false based off of if this is true. So as we see, the index 2 here, this value is less than 325, hence it's false, and the other ones are bigger than it. We can actually pass this type of thing into a pandas indexing. So what I mean by this is if we had rooms and then we pass this exact same thing in here, we do that, it gets only the rows that actually match the condition as true. So for all of these trues, it's going to keep those, hence we have index 0 here, we still have 0 here, except for 2, this value is false. It actually didn't even include that in this data frame. And we can see here we only have 11,000 or so rows with the same number of columns, except we're missing so many values. Now there's a lot of other similar things we could do, like less than, or checking whether something is equal to another. That's very useful if we're working with string data, which we'll use shortly. In fact, let's actually get some string or text data into this data frame because we've only been working with numbers so far. In fact, if we do rooms.dtypes for data types, we can see that we've actually only worked with floating point data up here. And if we look at our full data frame here, df.dtypes happens to be entirely floating point or decimal values. This isn't always true. We often have text or date information. We won't look at dates too much, although they're useful. We will look at strings, and we have to add them into our data frame. So this following piece has nothing to do with pandas, but we're going to use it for pandas in our example. We're going to pip install. This is just how you get a library names, and then we can use this library called names and use this thing called names.getFullName. And what that does is gets a random name after we import the library. Sorry about that. We do import names, and then we get a full name, which is just totally random. And we're going to use this to add some new column here where we have a name here, a name here, a name here, and that way we have some string of random names in our column. Now to do this, we're going to use the function called apply, and this is on a data frame. So we can do df.apply, and then what it asks for here first is a function, and we're going to pass it what's called a lambda function. And if you don't know what that is, let me show you with a very simple example. If we had, say, the lambda function, I'll put it in brackets, lambda x, which all it did is 2 times x, and we could call this by putting it in brackets here. So basically just treat this as a normal function. We call it, and then we give it 5. That's what passed into this x here, and so it does lambda 5 and then 2 times 5. So what we'll do for this lambda function instead, I'm just going to delete that. We have lambda, and actually what it takes is a row of information. It's going to take the first time, it'll take this row, and so it has all of the access to these values, but just for this row. Then the next time it runs, it'll go through this row, and it's basically iterating through rows here. And so here we do lambda row, and then, well, to get the value of just a random name, well, that's actually not dependent on the row at all. We can really just make it return names.getFullName, and that makes it return a random name. And then the other thing we need to pass here is access equals 1, which honestly don't really worry about that. What we're saying is we want to go through and iterate over rows instead of iterating over columns. So what this ran here is gave us a full series of length 17,000, because that's how many rows that we had, and each of them are a new name. And you can add a column to a data frame very easily by just this syntax where we set df and then we add some name here that doesn't exist. Df sub, we'll just say random name. We set that equal to this series object, so it's going to add a new column here. And so if we output df.head, we'll see the following. Truthfully, I meant to add this to rooms instead of data frame, but df is fine as well. So in the whole thing, we have a random name associated with it, and we can see if we ask the df.dtypes, we'll see that the last one here is an object, which actually, really, it's a string. Now, if you were running this along with me, we actually had to do this twice because of how I did the tutorial, and you'll notice it actually took over a minute on Google Colab to finish this. Doing this operation, apply, what it's doing is actually going over the first row, running the function, going over the second row, running the function. And if you don't know this concept called vectorization, that's okay. But basically the idea is that we want to try and do, say, the first 5 all at the same time, or all of them all at the same time. We're vectorizing or parallelizing rather than looping through each one of them. I'm not going to cover how to do that in this tutorial. I just want to let you know that it exists. Look up vectorization in Pandas if you are having trouble using this and it's taking too long. Now, we used the apply function on a data frame, except we didn't actually use the row that was passed in here. And so now I want to do basically the same thing here, except show you that we can base the value of our function here, the result, basically what would be contained over here, we can make that a function of the row here. So we'll do random name plus random name. This is just going to be a random name and then another random name, except the point is that we'll have a column here where it's going to have the first name here plus another random name. We can do this by doing, well, if we have access to the row, this is just going to be row sub random name. Okay, I can get that in here. And then if I do that plus a random name, but actually it's not really random name, it's really the other random name plus random name, terrible column name, but doesn't matter. And as we can see, that resolves exactly what we wanted. So we saw we could base the value over here based off of the values or possibly other values that are in the row. The last way I want to use apply, which is a very useful function, is with a series instead. We can do pop, remember we had this as a series as the population. Well, we can do pop.apply, except there's going to be 2 main changes here. One is that the lambda function, it's not going to take a row of information which has access to this and this and this. It's just going to be the value because that's all we have access to. And the other change is that we don't need to specify an axis here because we don't need to think about it rows versus columns. It's really just a column or a list of information. So what we can do, and maybe we just want to square this information, lambda x, which is just a value, is return x squared. And we can see here, it's just the value except it's squared. We could, of course, set this equal to the column over here if we wanted to make another column, but I'm just going to leave it as that. Now, something that might come up is constructing a data frame from scratch. So we do pd.dataframe, and then what we do is pass it the data, which is actually going to be a dictionary, where its keys are going to be strings, which are names of columns, and the values, well, if we tie a value to a column, well, we'd think this is going to be a list of values. Maybe call this first column in strings, and then we give it a value with the colon here, and we'll give it a list, which is, say, 1, 2, 3. They're going to be integers. And then we could also give it another value, maybe second column, and make this a list of, say, strings. This could be hey and hi. And what I purposely did here is gave the first one 3 elements and the second one 2 to show you that the arrays must all be the same length. That makes sense because we want it to be a table of information. This thing would be kind of messed up if it wasn't. So we're going to add another thing here, hey, hi, and Joe, and then we have the first column is these values, and the second column is these values. So that's how you might make a data frame from scratch. Often you already have your data in either a CSV or like a pickle file or maybe from an Excel table. There's many different Pandas functions which you can look up, which all it's going to do is change the way you load your data at the top, and then from that everything else is going to be exactly the same. So in most circumstances you wouldn't actually make a data frame from scratch, but here I am in particular to show you an issue that comes up in most data sets, which is the concept of numpy.notAnumber, which is actually just a null value. Okay, it means missing data. A lot of the time we have in Pandas data frames missing data, and here it's represented right here. This value, it shows up as NaN. It just means it's not really anything. It doesn't exist, but we need a placeholder. We need something to be there, otherwise it's not a valid data set. To mess around with this, I'm just going to call this new df is equal to this, and we'll output its head as normal. Now this missing data is a huge problem for us, and let me explain one reason as to why with an example. So maybe you wanted to do an apply. So df.apply, well, I could give it a lambda, and so I'll do lambda row, and then what it does is row sub second column, and then we return that plus the string of 5, and we have to set axis equal to 1 for this to work. Now, it doesn't like this because it's saying we're trying to add floats and strings, and that makes no sense because clearly this is a string, and we're clearly adding a string, so the problem lies in this thing right here. Now, most commonly, people just get rid of rows of data where they have any sort of missing values as to not deal with them. There's other imputation methods like putting in different values values, like maybe if these were floating points, we could put in the mean value for the column or some sort of other guess, except for us, what we're going to do is just completely remove any row that has any sort of missing data in here. So to do that, I'll just add a new cell in here, and what I'm going to do is I'll set new df equal to new df, except what we're going to do to it is we're actually going to drop NA. And then if I output this thing for you, you can see it got rid of that full row. This thing doesn't exist anymore. This problem doesn't exist because if we try to do the apply, it's okay because they're all strings, and this is the result that we get back. Now let's be honest, we're probably going to forget 99% of the syntax that we looked at. Let me just remind you of the things that we did so you can look them up when you need to know. So we started with importing the library. We had a CSV. It'll often be from a CSV, maybe an Excel table, or something online like an SQL database. No matter what, we get it into a data frame and we get a bunch of values here. We can look at an individual column, which is a Pandas series, by doing this. We can ask particular statistics on it, like maybe the mean of a column, standard deviation, min, max, and so on, or we could just describe it all at once and ask all of these things for a particular column. We can also get particular columns of a data frame, and so we get another data frame back, and then we could do the head so that we don't have to look at the whole thing. These statistics also work on data frames. It just gives us the result for each column. So here's the minimum for the total bedrooms and the minimum for the total rooms. We can also describe the entire data frame, and it's going to give all of these statistics at once. And here it is on our massive data frame. We can call a histogram on particular columns to look at each of the values and see where all of them seem to lie. We could also call hist on the entire data set, except that can be a little bit ugly at times. If we wanted to convert it to a NumPy array, this is how you would do it. We can make a scatter plot of the data with plot.scatter and then provide different columns of the data frame, and that'll give an XY data frame. And that'll give an XY plot of the data. We could look at some of the measurements, such as the correlation, and to grab particular values, well, we could ask the index of this thing with .loc, and we could grab that particular thing. We talked briefly about this concept of the index, which is basically this column here. We can filter the data set and provide such expressions like this is greater than this, and that'll produce this series of booleans. And then if we give that into this syntax here, we can actually ask the data frame only where these things are true. So it only provides the rows where this is true. We can always ask for the types of data in the data frame. We looked at this thing called apply, which takes a row in a data frame, and we can go and iterate over each row and produce a new column. We didn't actually have to set it equal to this new column here. We could have just produced a series, except we decided to add it to the column so that we had it over here. We saw that we can actually base the new column value off of the row, and we can get whatever data we want from each individual row. We could make it a function of the longitude, the housing median age, or population, or whatever we wanted to do. And we could also do this just on a series, and so it's just going to be a function that takes a value and produces something. We saw how we can make our own data frame with a dictionary where the keys are strings and the values are going to be lists of a specific data type. We saw this concept of missing data. If we ever see stuff like this, then we know that we should drop NA. If we ever see stuff like this, maybe we should just drop it or look up some of the other things we could do around that. And once we get rid of the missing data, we're good to do whatever we want. So I hope you learned a lot about pandas. If you did, please drop a like, and if you want to subscribe, I really hope you do. Please subscribe as well. I'll see you in the next video.